Okay, good morning, everyone. Thank you for giving us the opportunity to present our research paper at ICCR8. And our study is titled Uncovering the Drivers of TikTok Virality, Featuring Importance Analysis of Hashtags Using Machine Learning. And this research is conducted by Michelle Asia Angel and also Muffin Ferdinand Tanzo from the School of Computer Science, Venus University. And this work was carried out under the supervision of Punovianti Trimareta Sagala and Buli Ayu Wulandari. And in this presentation, we aim to demonstrate how machine learning combined with explainable AI can be used to identify the key drivers of TikTok virality with a particular focus on the role of the hashtag usage itself. And here's the structure of today's presentation. We will begin with the introduction and literature review, followed by the research problem and objective. And the next one, we will explain our methodology, present the results and also the analysis, and conclude with the key findings and references. So TikTok has emerged as one of the most influential short-form videos platforms in this world, driven by a unique content phrase, user second recommendation algorithm. And unlike the traditional social media algorithm, video distribution on TikTok does not primarily depend on the creator's follower count. Instead, any video can reach a large audience if the early engagement signals are strong. And within the system, the user engagement, especially likes, serve as the most reliable indicator of the virality due to its strong correlation with views and shares, as supported by the prior studies such as Ling et al. And San Yunjo et al. So, TikTok operates under a content-first algorithm recommendation system, where algorithmic amplification is driven by content performance rather than social connections. So, newly uploaded videos are immediately tested with a small audience, and strong early engagement can rapidly push the content into wider circulation. So, this creates a highly dynamic and competitive environment where the virality emerges quickly and often unpredictably. And within this ecosystem, engagement metrics guide the algorithmic decision. So among these metrics, likes are consistently identified as the most reliable proxy for virality, showing the strong correlation with both views and share. And as a result, predicting and explaining the variations in likes provide direct insights into TikTok's recommendation behavior.
Hashtags as algorithm signals. Many creators widely rely on hashtags to signal topic relevance to the algorithm. However, existing research provides mixed conclusions regarding their actual effectiveness. Most studies evaluate hashtags using simple frequency or count-based approach, overlooking the semantic meaning created by hashtags used together. This limitation leaves a gap in understanding whenever specific hashtags structured truly contribute to virality. Engagement prediction using machine learning. Due to the nonlinear and high-dimensional nature of social media data, traditional statistical models often fail to capture complex interaction patterns. As a result, machine learning models, especially in regression models, have become the dominant approach for engagement prediction. Tree-based sample methods, such as random forest regression, are particularly effective due to their robustness against sparse features and skewed distributions. N-gram analysis for hashtag combinations. Most existing studies treat hashtags as independent features. However, in text mining, n-gram analysis is widely used to capture semantic context by analyzing sequence of words rather than isolating them. Applying n-grams analysis to hashtags allow us to identify meaningful combinations such as biggrams and trigrams that may signal trends, challenge, or content niches on TikTok. Auxiliary features and model interpretability. Beyond hashtags, TikTok engagement is also influenced by content native variables such as music selection and trending audio usage. To avoid biased conclusions, these variables be included as control features. Furthermore, predictive accuracy alone is insufficient. To ensure interpretability, we employ SHAP SHAP, which enables transparent, feature-level explanations of model predictions. Research gap and study contribution. Despite extensive research on TikTok engagement, a critical gap remains. Few studies analyze hashtag combinations, and even few integrate interpretable machine learning frameworks. This study addresses that gap by combining ensembles regression, n-gram-based hashtag features, and sharp interpretability, providing both predictive and explanatory insights into TikTok virality.
So, the primary objective of this study is to analyze and explain the key drivers of TikTok virality using machine learning. Specifically, we aim to predict the number of likes as a proxy for virality, evaluate the contextual impact of hashtag combinations through n-gram analysis, and interpret feature contributions using SHOP to provide actionable insights. And on this slide, we present our methodological flow starting from the data collection, exploratory data analysis, preprocessing, feature engineering, modeling, evaluation, and finally the model interpretation using SHOP. And here, we use approximately 7,225 videos, TikTok videos sourced from the publicly available TikTok 2025 dataset on Kiko. And the dataset itself includes the video metadata, hashtag, user information, and engagement metrics. So our target variable is likes, which is log transform to address the extreme skewness, and the model is developed in Python using scikit-learn in SHOP with the random forest regressor as the primary model.
Data preprocessing. Before transformation, the last distribution is highly risk-skewed, dominated by extreme viral outliers. After log transformation, the distribution becomes more symmetric and suitable for regression modeling. Hashtag frequency. Unigram analysis shows dominance of generic exposure hashtags such as FYP and viral. Bigrams and trigram frequencies further reveal that creators frequently stack algorithm-oriented hashtags, indicating reliance on visibility strategies. And this is for the n-gram patterns. As we can see, that this is the top 10 bigram frequencies, and this is the top 10 on trigram frequencies. And for the structure, the co-occurrence network reveals a dense core of generic hashtags, as acting as a hubs surrounded by smaller thematic clusters. This suggests that niche content is typically paired with broad exposure hashtags rather than used independently.
So the random forest regressor outperformed the multiple linear regression, achieving an R-squared value of 0.608 and reducing the average error into 11,260 likes. So this confirms the presence of nonlinear relationship in the TikTok engagement data. And the next one, after evaluating the regression performance, we further assess the model using a binary virality classification setting. So the model achieved an overall accuracy of 81%, indicating a strong generalization in distinguishing viral and non-viral videos. So for non-viral videos, the precision reached 0.92, showing that the model is highly reliable when predicting videos that are not viral. And more importantly, for viral content, the model obtained a recall of 0.81, which means it successfully identified most fully viral videos, even though the precision is relatively moderate at 0.661. So overall, these results demonstrate that the model is particularly effective at capturing viral content, which is critical for understanding the TikTok virality dynamics.
Model interpretability. The shop summary reports that log plays, log shares, and log comments are the most influential features driving the model's prediction. Hashtags and temporal features contribute marginally, indicating that early engagement dynamics dominate virality outcomes. To conclude our presentation, the random forest regression outperformed the linear baseline, achieving an off-to score of 0.608 and reducing the prediction error to 11,260 average lives. Meanwhile, in the virality classification, the model reached an accuracy of 81% and successfully identified 81% of viral videos. For the feature importance and sharp analysis shows that log plays, log shares, and log comments dominate the predictions, while hashtag based on temporal features exhibit minimal impact. These findings quantitatively demonstrate that early engagement metrics are the primary drivers of TikTok virality, outweighing posting time and hashtag frequency. And here are the key references supporting our study. I think that concludes our presentation. Thank you very much for your attention and your time. We would be pleased to answer any questions or engage in further discussion.